Here's the database diagram for our database. Everything revolves around the chicken because this database is intended to keep track of chickens and their attributes. So we'll start off, we have a chicken which has a breed ID, which refers to the breed table. This is just like the type of chicken that is in the database. You have the gender and birth date of the chicken, and then we also have a food ID, which refers to this table. This is just what type of food the chicken eats, basically, so the people know what type of food to buy for their farm. You also have a death for the chicken, just in case the chicken dies. You can keep track of the date. And then also, you can keep track of when chickens lay eggs with the lays egg and the pedigree table. The pedigree table is a hub between these two tables. And whenever a chicken lays eggs, you'd make a new lays egg instance, and then you'd specify the number of eggs that were laid and the date that those eggs were laid, along with the breed ID. And then the pedigree links that with whatever chicken you specify. And then the other main part of our database is the customer and sales tables. The customer has an address, date bought, phone, email, all the credentials of the customer. And then the sale, you specify the customer ID that would be making the sale, and then you can either specify a chicken ID, a carton ID, or both. So if the customer were to only buy a chicken, you'd only specify a chicken ID, and then the carton ID would be null, and vice versa. Or a customer could buy a chicken and a carton. So for each sale, you keep track of that. And then a carton just refers to a carton of eggs, so a customer can buy a carton of eggs, and then you see what type of eggs are in the carton, and then the price of the carton. So that pretty much sums up everything. So here's our actual database. We have the 9 tables that have been set up for data. We have 3 views. We have a view to view the entire database and all the rows in it. We have a view to view the chicken details. And then we also have a view to look at either the amount paid for a chicken or for a carton. So one of these values should be null. And that allows you to see what is being paid for a specific chicken or carton of eggs. If we go to programmability, we have our stored procedures. We have 27. We have 9 for deleting, 9 for inserting, and 9 for modifying, and 1 for each table on the database. So say we wanted to delete a customer, we would just execute this, and then we'd specify the customer ID that we wanted, that refers to the customer that we're deleting, and then we would delete that. For inserting a customer, you would specify everything besides the customer ID, because the customer ID is on auto increment, so that would be added automatically. And for modifying, it's the same thing, except for you do specify the customer ID so that it knows what customer to refer to when you're modifying. And then also a little bit extra, we have a safety trigger. This allows you to lock the structure of the database so that tables can't be added and dropped and modified. That can be handy for when the database shouldn't be changed at all, but when you want to change the database, you can just disable this easily. So that's another cool function. So whenever you add a chicken, you need to make sure that you specify the breed, and if you're adding a chicken that has a new breed, you need to specify the breed first, because the chicken needs to know what breed it is. And then you also need to have a food type for the chicken. These are both required. Also, if we're adding a sale, we need to know, we already have to have a customer in the database that refers to the sale, and then we either have to have a carton or a chicken or both that also will be included in the sale. Whenever specifying the laying of eggs, we insert a chicken, which might already have been done, and then you insert the instance of when the chicken laid the egg, and then you insert the pedigree, which is, this is the hub table between these two. It has to be done in this order because the pedigree refers to both these tables. This is a little diagram showing how this could be made.